Okay, this video we're doing 3.22. This one has an air balloon that is going down at a velocity of 20 meters per second. Since it's going down, I made it negative. And then someone throws a rock out of this balloon at 15 meters per second. So that's just going down. And it says it takes 5 seconds for it to hit the ground. So the very first question that it asks us is, how high is the balloon when the rock is thrown? So what we're trying to find here, I wrote our equations already, is this initial y. So our very first y, like our final y, is when the basket's going to be on the ground. So that's going to be 0. And then that's going to be equal to yi, which we're trying to find, plus the initial velocity of y, which isn't, since it's going down, the velocity of y, or the balloon, is negative 20 meters per second. And the time that we're trying to find is, let's see, the time we're plugging in is 5 seconds. And then we're going to do plus 1/2 acceleration of gravity times time squared, which is 25. Okay, just make sure I put that in right. Okay, yep. Alright, so then what we're going to do is we can either solve this stuff, which is just going to be minus 100 and something else I'm not sure about right here, and subtract it over. We can just subtract the y over and negate the answer, so I'm just probably going to do that. So you have negative yi equal to negative 100 plus 1/2 negative 9.81 times 25. And then when we solve for this side, what we're going to get is negative 222.5, and that's equal to negative initial position of the balloon. So then we're just going to divide by negative 1, and we find that our initial position of y is 222.5 meters in the air when the rock is thrown off of this balloon. Okay, and this is going to be important because we now need this number in our next equation. So let's go ahead and just let us know the height of this balloon. 222.5. Okay. All right. The next part of this question asks us, how high is the balloon when the rock hits the ground? So now we're trying to find the final position of this balloon when the rock hits the ground. It's not going to be 0 now because they're not falling at the same speed. Okay, and so we're going to set that equal to initial y, which we already know, we just solved for it, 222.5, plus, and now we are plugging in the velocity of the balloon again, which is negative 20 times time. And then, let's see, this time the balloon is falling, so the acceleration of the balloon, so there's a keyword when you read it, and it says that the balloon is falling at a constant velocity. So since it's a constant velocity, the balloon itself doesn't have acceleration, which makes this acceleration be 0 times time squared, which is going to be 25, but that's just going to be 0, so we're just going to erase that part. Okay, and then we'll solve for that right there, and when we do, we get that the final position of y when the rock hits the ground is 122.5 meters. Okay, and so when the rock hits the ground, the balloon is 122.5 meters in the air. Okay, now we're going to do part C. Part C says, at the instant the rock hits the ground, how far is it from the basket? So now we're going to do triangle stuff. Okay, so when the rock hit the ground, the balloon was 122.5 meters in the air. Okay, so now we need to find, if we can find this x distance, then we can solve for the hypotenuse, which is going to be how far the rock is from the basket. So to find this x distance, we're going to use this equation here. So xf, which is what we're looking for, is equal to the initial position, which is just 0, plus the initial velocity in the x direction of the rock, which is 15 meters per second, and it travels for time, which is 5 seconds. And that gives us 75, if I remember right. Yeah, 75 meters. Okay, 75 meters. So now we're just going to do the Pythagorean theorem. So this hypotenuse here, or the distance from the rock to the basket, I'm going to make it d, is equal to the square root of 75 squared plus 122.5 squared. And when we calculate that out, we get that our distance is 143.64 meters. Okay. All right, one more part. This is a long one. Okay, this one's more conceptual. It says just before the rock hits the ground, so pretty much at this point, it wants to know, we'll find its horizontal and vertical velocity components as measured by an observer at rest in the basket and at rest on the ground. Okay, so we have our observer, and they want to know the horizontal and the vertical components. Let's see. It's measured by an observer. Okay, so when we're at rest in the basket, then it's traveling in still the same horizontal velocity, which is 15 meters per second, and it's just following at the speed of gravity, which is, well, not the speed of gravity, acceleration of gravity, and that's going to be negative 9.81. Let's see. Oh wait, that's a picture of the next one. So for in the basket, so I'm going to write this equation. The acceleration in the basket, what we're going to see is 0 in the x direction, and negative 20 in the y direction. I guess we'll put our hats on there, and that's what we see from the basket. So for the second part, when on rest on the ground, then this is what we see for the second part.